Bismillahirrahmanirrahim. Now we talk about random variables, and first of all we start with discrete random variables. Discrete random variables, which is abbreviated with RV, is a function that assigns a real number x of zeta to each outcome zeta in the sample space of a random experiment. Suppose a coin is tossed 3 times and the sequence of heads and tails is noted. The sample space for this experiment is HHH, HHT. H is representing head and T is representing tail. So either you have got all the heads, or you have got 2 heads and 1 tail, or 1 head and 2 tails, or all the tails. So I've got 8 possibilities over here. Let x be the number of heads in 3 tosses. Here our random variable x is to determine the number of heads in 3 tosses. How many heads do you have? So the possible number of heads in 3 tosses is 0 when you have got all the tails. Now every time you toss the coin or flip the coin, you got tail. In that case the possible number of heads is 3. So in that case the value of this random variable x will be 3 or 0. And to have one head is HTT, THT and TTH, and to have 2 heads then you have got again HHT, HTH and THH, and to have 3 heads only in the case where you have HHH. So x is then a random variable taking on values in the set as of Sx is equal to 0, 1, 2 and 3. So here either you have got 0 heads, 1 head, 2 heads or 3 heads in case of 3 tosses of a fair coin. If the outcome of some experiment is a numerical value, we can immediately reinterpret as a random variable. So that is x of zeta is equal to simply zeta itself. How many times each value was repeated or it occurred? What is frequency distribution? We have to see that how many times a number repeated or that value was repeated. So for example, a batsman playing cricket scored the runs as given below. So on the first ball he scored 2 runs, on the second ball he scored 3 runs, and in third ball he scored 1 run, and so on. And this is the scoreboard of that batsman. So what we'll do is that we'll determine that how many times he scored 2s. As you can see here, 1, 2, 3 and 4. So you can see here that he scored 2 runs 4 times, 0 runs. In this scoreboard you can see that he scored no run on 2 balls. So the frequency of scoring no runs is 2. And what is the frequency of scoring 1? That is 1, 2 and 3. So the frequency of scoring 1 is 3, and so on. That's how we have populated this whole table. So in probability and statistics, distribution, what is this term distribution refers to or means in probability and statistics? It means that it is a characteristic of a random variable which describes the probability of the random variable in each value. So distribution that simply means that what is the probability of that random variable for each value we are talking about. So then now we come to probability mass function. The probability mass function PMF of a random variable x is a function that assigns a probability to each possible value of the random variable x. So for example, here we have got in this case we have got 0, 1, 2, 3. These are the possible values of x. So what is the probability of 0? Means having no head at all. Or what is the probability of having 3? What is the probability of having 3 heads? So this is called probability mass function. This probability mass function simply gives you or assigns is a function that assigns a probability to each possible value. The probability that the random variable x takes on the specific value x is the value of the probability mass function for x. So we write it like this: probability of x is equal to x. So what is the probability of for example, x is equal to 0 means having no heads, or 1 head, or 2 head, and things like this. Thus the PMF is a probability measure that gives us probabilities of the possible values of a random variable. Only discrete random variables have PMF. We can have PMF of only discrete random variables. By discrete we mean that like flipping the coin, or with the quantities or which we can count. Suppose a coin is tossed 3 times. Find the probability getting 0 head, 1 head, 2 heads, and 3 heads. So now we are going to find the probability mass function for these 3 tossing of a coin 3 times, and we will see what will be the probability of 0, what will be the probability of having 1 head, 2 heads, and 3 heads, and that will be our probability mass function. So how do we find this probability mass function? First of all, we say that probability of having 0 heads, means having no heads, is same as having probability of all the tails. And to find the probability of all the tails, is simply is that multiply the probability of having tail in each toss. So in each since we are using a fair coin, the probability of having head and tail is 50-50%. It is same. So the probability of having tail is simply 1 minus p, which is in this case p is 0.5. So 1 minus p multiplied by 1 minus p multiplied by 1 minus p is equal to 1 minus p raised to power 3. Now having just 1 head in 3 tosses, that is probability of head, tail, tail, probability of having tail, head, tail. So in the first toss you got tail, second toss you got head, and the third toss you got again tail, or in the first 2 tosses you got tail, and the last toss you got head. So how do we get the probability for each one of them? Is simply again like this: we have multiplied probability of head, probability of tail, and probability of tail. Since we are interested in head over here, so we call it success, we call it P, and the failure is 1 minus P, T is failure, 1 minus P. So P multiplied by 1 minus P and multiplied by 1 minus P, and similarly we have written for this one and this one also. And just simply using algebraic arithmetic, we find that P of x is equal to 1 is equal to 3p multiplied by 1 minus p whole square. In the same way, we have found the probability for x is equal to 2 and for x is equal to 3. I'm not going to go through all this again because that I have explained it over here. The method is the same. You can pause the video over here and you can see it yourself. So after getting these equations over here, we can find the probability mass function of x, where x is equal to 0, 1, 2, and 3. So Here we have just plugged in the value of P. Since as we in the beginning I told you that the coin is fair, so in this case the probability of having uh, um, the head and not having the head is the same, which is 0.5. so the probability of success is 0.5 and probability of failure is also 0.5. so we simply say 1 minus p is equal to 1 by 2, which is 0.5, and then we cube it and we get 1 by 8. So the probability of getting no head at all, or all the or three tail in all the three tosses, is 1 by 8, and probability of having 3 heads is also 1 by 8, and the probability of having 1 head and 2 heads is the same, which is 3 by 8 and 3 by 8. So as you can see, this probability mass function over here gives us tells us what is the probability for each event. If you get 0 head or 1 head or 2 head and 3 head, so you can count that by using this PMF.